9 starts out with some concepts about real numbers. These concepts are going to be needed for the more advanced algebra equations that we will get to. So the first concept is square roots. Square root of a number, and we're going to call that number n, is a number, and because we're just talking about all different numbers, we're going to call that one m. Now the rule says that if you squared m, it would equal n. Sounds like I'm speaking a different language. So when you get it in action, it's going to make a lot more sense to you. So every positive number has two square roots. One square root is positive and the other is negative. The radical sign, which the radical sign is this sign, represents a non-negative square root. The symbol reads plus or minus, the symbol plus or minus refers to both square roots of a positive number. So what that all means is this is the square root of 100. So the square root of 100, that's our letter n. How do we get to n? Our letter n, let me just put those letters in there so you can refer to the text there. So this is what our letter n was, and this is going to be our letter m in that definition. So the way I understand what the square root of n is by that it says it's equal to 10 because, so here's going to help you with the explanation that's in black there. If I did m squared, which would be 10 squared, that would equal the n number under the radical sign, which is 100. Now in the next equation, notice that there's a negative sign and it's outside the radical number, or the radical symbol. So it's negative, or the opposite of that answer. So under the radical is still 100, so our answer is still the 10, but then in front of the radical, we have our negative, so our answer now is negative 10. Now what that means is, again, if we go back to our n's and our m's, this time our m is a negative 10. But if you square a negative 10, remember that would be negative 10 times negative 10, you would still get the positive 100, which is the number under the radical sign. This time, and they told you to read this as a plus or minus, or it could be a positive or negative is the way I would refer to it, of that, the square root of 100. So again, take that symbol and you're going to keep it with your answer then. So if it really was the positive square root of 100, it would be a positive 10. If it was the negative of the square root of 100, it would be a negative 10. Moving on, we're going to talk about a chess game, kind of cool chess game that they do where the chess pieces are really real people. The people that are the knights even ride horseback. So now we have to put the math part into it. You've got your little it's history or interesting fact there, and now we're going to put the math into it. The chessboard is a square with an area of 324 square meters. We need to know what is the length of each side of the board. So we're talking area here. Here's our board, and if it's a square, it's going to be the same length on one side as the other. And when we're figuring out area, we multiply both sides. So it would be x times x, which would equal x squared. So when we look at this one, it tells us that our equal is 324 meters. So what we want to do for each side is figure out the square root of 324, right? So I'm going to impress you here because the book just tells me this, and we'll show you in a little bit how you can figure this out. But I know that 18 times 18 happens to equal 324. So that means the square root of 324, remember in our square here, this whole area is 324. If each side was 18, 18 times 18 would give me that 324 square meters of area. Moving on, we're going to learn how to approximate the square roots. And I will tell you this is in your book, so you'll want to have your textbook handy when we're doing the practice. But it tells you a perfect square is a number that is the square of an integer. And some perfect squares are 1, 4, and 9. The reason we call these perfect squares is because 1 is really the product of 1 squared, 1 times 1. 4 can be the product of 2 squared. 2 times 2 equals 4. And 9 is the product of 3 squared. 3 times 3 is 9. Those are called perfect squares. In your textbook, you have a whole page of all the square root values, and in there you will find the different perfect squares. So these are ones that you probably know mentally. You go down here, 6 times 6 is 36. 10 times 10 you should know. The ones below 10 you might have to do a little memorizing. These you should be able to get to. Remember, your biggest thing is when you're doing squared, that is not 6 times 2, it's 6 times itself. And that's where you get your 36. So moving back to our example 2, this time it says approximate. That means you don't need to have the exact number or answer, and you're going to use that wavy equal sign. We haven't used that for a while. So approximate the square root of 51 to the nearest integer. So we want to have a whole number there. So we're going to go ahead and we're going to look at our perfect square chart. And I see on our perfect square, I'm looking for 51. It's not on there. It's not a perfect square. But I see 49 and I see 64. 51 should be somewhere in between there. So I'm going to say that 51, because it's in between 49 and 64, and these are perfect squares, so the square root of 49 and the square root of 64 in there should be the square root of 51, which is what we were trying to approximate. So the square root of 49 is 7. It's one of those perfect squares. The square root of 64 is 8. 7 times 7, 49. 8 times 8 is 64. So my answer is going to be for the square root of 51 somewhere in between 7 and 8. Now we're looking to see which one is 51 closer to. 51 is closer to the 49 than it is the 64. So I'm going to say that 7 is about the approximate square root of 51. And if you look at your textbook, you will see that it's 7 point something. I didn't make the whole chart on our mini lesson. All right, now we can do this on a calculator as well. And when we do it on a calculator, we usually round to the nearest tenth. So doing this on the calculator, you're going to look for the button. Notice I kind of rounded that to show you the button that says seconds on it. You're going to hit that button, and then you're going to hit the square root button. Okay, those two buttons. And then you'll put in your value that is under there. So for this one, you would type in 515. When you do that, the display is going to come up with 22.69, and it's going to keep going. So I told you could round to your nearest tenth. So you really only need to look at it this far. 9 is greater than 5, the halfway point. So my answer there would be it's about 22.7. Okay, so the square root of 515 is about 22.7. That's using the calculator, and you will be able to use that. And so now we get to do it as an equation. Okay, the equation is going to be a little bit different here, and we're going to say that they're going to give us some values. So the first thing that we're going to do is substitute those values in. So now I have 2, the square root symbol, and we have 11 plus b squared, and b is 5. So I'm going to go ahead and I can put some numbers in here. Just because I'm running out of room, I'm going to move it over to the side here. So 2 square root 11, I don't have to do anything there. What's 5 squared? 5 squared is 25. So I have 11 plus 25. So my new equation is 2 square root of 36, 11 plus 25. And 2 times the square root, and this is the radical symbol here is acting like a parentheses when we used to do parentheses. So it's going to be that it's 2 times this number because I can simplify the square root of 36. Square root of 36 is going to be 6. Can I replace that with parentheses? And when we have numbers next to each other with parentheses, that means to multiply them. So 2 times 6 is going to equal 12. So this very difficult or advanced looking equation, you are able to solve with all the knowledge that you've gained just in this one lesson, that is going to be, the answer is going to be 12.